Today I'm going to take you through a network troubleshooting journey, okay? This is my new startup here, it's called Monitor Monkey, and I was working on the graphing. Specifically, I was working on this bit of the graph here, where you see the total download and total upload. Now, when I viewed my daily graph, it said this was about 120 gigabytes. And now I was like, what the hell? Why am I doing 120 gigabytes a day? That's insane! So, join me as I show you how I investigated why this was happening. So first you've got to think back to first principles. How do we find networking information in Linux? There are many tools you can do it, but the kernel provides you an interface and it's in the proc file system. So this is my server here, and if we look in proc, there's a ton of stuff here. What is going on? Everything in Linux is a file, but proc are special files. These files in proc, they're created by the kernel as soon as we read them, which means they contain current information. They're an interface to the kernel, and you don't need to use any fancy C libraries to interface with it. We're only talking about networking today, so we want to look in proc net dev, the proc net, and specifically dev, like this file here. So if we look in this file, we see all this. What's going on here? Why is it so complicated? My face is not in the way of anything. I promise you it's just more zeros. I'll move myself anyway. So there are two parts here. We've got the receive and transmit of our interfaces, specifically loopback and eth0. These are the only interfaces on my system. And what we're looking for is bytes and packets, okay? If you see any errors, that's probably something for you to investigate, but not for me, because I don't have any. And immediately I see a problem here. My tool was monitoring every interface by default, so my startup would monitor your whole interface, which means it would monitor loopback. Oh dear. Why is loopback being monitored? Because I'm an idiot. It's not anymore. But I wanted to know what was happening on my loopback interface. So to do that, we need to use other tools, because this only tells us what packets are being, how much is being sent. And it's a hell of a lot, by the way. That's a stupid amount. I mean, the server's been up 42 days, so that's 42 days worth of traffic on loopback, which is nuts. Anyway, I'll tell you why that's maybe not as crazy as it seems in a second. But first of all, let's take a look at inside procnet again. And there's a ton of files in here, and they all do what they say on the tin, right? So if you want to see TCP information, you look in here, and it will show you all your TCP stuff. Unix, this is cool. This is things using Unix sockets. So you see here, it's some systemd stuff and whatever. But anyway, so I wrote a script to sort of convert those bytes from procnet into actual values, and you can see how crazy it is. So this is the agent that runs on the server, and I just added a little print at the start that would dump the details. So on loopback, there's 45 gig sent and received effectively, and it's actually exactly the same amount, which kind of makes sense once we dig in further. And then on the interface, it's 8.9 gig in, what is that, 42 days, which kind of what we expect, okay? That's not a crazy number for what this server's doing. How this actually works, by the way, is it takes the difference of whatever's in here, so proc, so you take proc net dev, you cat that file, and then you sort of get this value here, and then you cat it again in 5 seconds, and you get, and the value is different, and you basically compare the two, and then you get how many bytes you send. So if we do it, we got this, take away this equals that. I've done it the wrong way around, haven't I? So it's actually, this is the bigger one, take away the old one, is this, and then you convert this into kilobytes. So it's 12 kilobytes, there we go. Which, if we look in the last minute, I have used 280, so that makes sense, okay? So that's what the tool does. And that's how you can use proc yourself to monitor. There we go, no external tools needed, just proc and some greps. And I use Python to calculate because I don't know how to use BC and it's not installed. So how do we see the traffic and what's actually using my loopback interface? So I already had a hunch that it was my database. But to confirm that, the first tool we'll take a look at is tcpdump. If you're unfamiliar with this, it's like command line Wireshark, and very simply, I want to do tcpdump-i for interface ally. And then it's a bunch of packets, but as we can see, it's mainly Postgres here. Postgres talking to itself, basically, or being written to. And you can also export this to a pcat file if you so wish, which you can read in Wireshark. So tcpdump is the first step, just seeing the raw packets on the wire. So digging further if we so want, we can use lsof, which stands for list open files. However, because everything on Linux is a file, we can also see things open on certain interfaces. So if I put my local address in here, boom, this shows what is currently open. So we have Postgres and we have cronny. Kind of expected. Cronny is NTP, so network time, and Postgres is, well, Postgres, my database. That's more information. Very cool. Let's use another program to dive even further and see what is using the most amount of data. So we can use iftop for that, like interface top. It's like htop for your interfaces, so -i loopback. And here we go. So this shows localhost is talking to itself, and it also shows just how bloody much data we're using here. So we're using a fuckload of data. But again, this genuinely isn't really useful for loopback. It's more useful for like your default interface, because you can see all the traffic. I don't want to dox myself here, or my clients, because this shows people who are using my startups where they're coming from, which so I'm not going to show this, so this will be blurred here, but there is a lot here, and this is more useful for, well, it's really cool because you can like debug who's going where, basically. Right. There's also another program we can use called nethogs here. So nethogs shows the actual process and program name that's being used. It's a bit like lsof, but slightly more detailed, so we can see we've actually got some Apache stuff here, and this is going since we run it. So my agent, which technically talks to itself here because I'm dog fooding, right? So I'm monitoring the server with the monitoring software, so it talks to the local host instead, right? And this is the database here. You can see it's doing a select statement here. Very cool. And Apache, and because Django talks to Apache, and there we have it. So you can see why these might be useful for slightly different purposes, but they all kind of serve the same function, except tcpdump, which is reading the proc file system and displaying it nicely for you. tcpdump is different because it lives on the wire and is actually sniffing the packets as they come in, not using the proc file system. So the downside to using programs that I've shown you and the proc file system is you have to run them sort of live, per se. They have to be ran and then you have to go look at them. So you could run them in a screen session and come back and look at them if like a day later or something, but that's not very nice. And you can make them log and then read them back, but I've always found that to be a bit clunky. So if you want to know more about your network interfaces historically, there is another program you can use, and that I used for investigation, to basically make sure that my eth0 wasn't very, very chatty. And to compare values, I used a program called vnstat. Now vnstat actually runs as a daemon, so for me it runs as a systemd service here. And it doesn't capture per process, it captures per interface. Now, for some reason, I actually can't get it to capture the loopback interface, but that's fine. All I was using it for was to compare the values. Like if we look at hourly here, it's 12 meg, and then if I go on to vnstat, and I can go dash hour. What was the last hour? 12 meg. There we go. Might be some slight differences in when the hour is and calculation, because this is actually an hour from now, whereas this is 7 till 8, which is why 8 here is only 3 meg. So that's why there's some differences, but that proves to me that what we're doing now is correct. And so vnstat, by the way, when you run it by default, will just spit out a nice little graph for you, and gathers data all the time. So we can do more commands with vnstat. So as I showed you, we've got -h, means hour. So we can also do -what for day, d, correct. Whoa, so intuitive. Can we do -w for week? No. Can we do -m for month? Yes. Okay. So vnstat also has a cool live view. As you can see, it gathers traffic first and then starts outputting what we're seeing live. If you want to look at it on the terminal, you can. But I just prefer running it like this to compare to what my tool's showing. You can also show sort of graphs. So you can do HG and you get like an hourly graph. It's got that spike there. So I'm going to see if we can see the spike on my start button. We do have that spike there, look. So we can sort of see that it is accurate. We've also got, it shows you a top 10 view, which is like your top 10 days. So there we are there. Now the downside with vnstat is that you obviously won't have the top 10 tool if you haven't been running the tool for 10 days. So I've probably been running it for only 10 days. So vnstat stores its data in var lib vnstat, and there's the database there. It's its own binary format, and we can probably see some SQL commands, but as you can see, it's using not much data. So yeah, you can sort of tell what it's doing, but it's a binary, which is why it's so small, right? So there we go, that's vnstat, and now there is also another cool tool that comes with vnstat if you compile it. So I had to install the package vnstat vnstat I. I'm on Rocky Linux here, and that gives you access to the tool vnstat image, okay? And I should point out that these vnstat has extremely good man page, and so does vnstat. I imagine maybe you don't need to install a separate package depending on your distribution, or if you're on Gen 2, you know, you can compile vnstat with vnstat using a use flag. So let's just generate a summary image. So we can go vnstat vs for a summary, and then o out.png and now we have this file out.png. Here's some I made earlier, but let's get out.png from my server. Let's just use SFTP. Don't have to remember the bloody paths then. Get out.png. There we go. Now if we look at out.png, there we go. So we have this little image. So that image is cool, but it's not very useful. If you want to make it useful, we could cron this summary and upload it to a web page, right? That only we can access, and then we can refresh it and we get a semi-live view, if we generate this once a minute or whatever, of our current networking. And we can also generate others with it. And vnstat actually provides a script. This is on their repo here in examples. This is a CGI script, so if you've got Perl, you can run this script here, put it in your web root basically, and then whenever you visit it, it will generate a page. And this is from the vnstat official website, and here we go. Look at this, very cool. That's very cool. So there you go. I just wanted to take you through the journey of me investigating why my loopback interface was so yappy, and hopefully you learned something about network monitoring. Very cool. Use my startup if you want to monitor your Linux servers. Everything that runs on your server is open source, so no biggie there. Don't, it's fine, because you can use vnstat instead. Hey!